In this video, I'm going to go over SQL in 10 minutes. It's a book on Amazon Kindle, which I bought, and it teaches you how to do SQL in Access. So it also does a few other databases, because SQL, there are SQL for SQL Server, there's PL/SQL, there's Oracle SQL, there's all these different types of SQL, but the focus of this video is Access SQL. So I have Access open right here, and here is the tables, here are the queries. I'm not really going to go over a lot of Access stuff. I'm mostly going to go over the queries, the SQL queries in this video. So here is the customers table, here's the order items table. If you want to create a table, go up here and you go to table, and let's go to design view. So see this key here? If it's not there, you can just right click and then do primary key, and then all the primary keys, they are a unique identifier for, it's like an ID key for that table, and it needs to be unique and it can't be blank. So over here under required, you write yes, because there needs to be data there. And then you basically click save, and then the table appears over here. And let's just go like first name, short text. Let's go to datasheet view, and then you could just like start entering stuff like customer 1, and then the name would be like that, and then you could just like add another customer, etc. Then you click save, and so that's that table. But here are the tables I'm working with. We mostly work on the products table in this video, so I have a screenshot of that over here. So I'm just going to go right over to the relationships real quick in this database. So this database, it has relationships between the different tables, because a good thing about Access is you store data for each group of items in a separate table. So you have the orders over here, and then you have the order items over here. So you kind of break it out by detail, because you could have like multiple items in each of the orders, but you only have a single order, and each of the orders are unique in themselves, and then they could have multiple items in that order. And then see this one, that means single, so there's a single customer for each of the customers in the customer table with all like the address information. And then over here in orders, it's a many and the infinity sign. So the customer, they could have many orders, and then each of the orders, there's only one single order for that order number as the primary key. And then over here, the order number, there's many. So this order number is actually a foreign key, so it's many, and the primary key in this order items table is order item, because that's the unique one, and then order number would just be the many. And that's basically the relationships for this table. So I'm going to close this. And so SQL is structured query language. Lets you store different tables and associate, join the tables, and run different queries, and retrieve data from like large databases. So here's the first query. I'm going to press Alt+VQ to go to SQL view, but let me just right click here and go to design view, and then datasheet view. Datasheet view is the table, and then SQL view is where you write the SQL. You could also go up here to design and go to view and go to datasheet or SQL. So I'm just going to press Alt+VQ for this video because it's faster. I don't have to click. So this query is the first query. It's a select. So you select the product name, which is this column in the table, products. So this is the products table, and you basically select product name from product. So fish bean, bird bean, queen doll, etc. So here's that data right there. So that's what that does. Here's the next thing. This one we select multiple columns. So you got prod ID, prod name, prod price. Select prod ID, comma, prod name, prod price from products. Products is the table up here. So you click run, and you select each of those columns from the product table. Say here's all these over here. Here's all these over here, and then all these over here. So that's how you retrieve those. Here's how you select all the columns. You go to select and then star from products. So star indicates all, which is basically you're just selecting everything. And then let me just open up my notes real quick. So over here, go to Alias. So Alias, you can use an alias on a calculated column, which I go over down here, mathematical new calculated field. Or you could use Alias to shorten the table names. So I'm just going to go to SQL view. So how this works is, so you go to select, and then here's C period star, and then from customers as C. So you select, you turn like this table customers, and you use an alias AS as C. So now this table is known as C. So you do up here in the select statement, you do the table name and then dot star. So that selects all of the columns from the table C, which is customers. So it's basically, this is the same as writing customers dot star, except it's just C dot star, because you use an alias to make customers known as C. Like at minimum for each of the SQL queries you have, you must have at least a select and a from statement in them, because you want to either select data or you want to select it from a table. And then you add, like down here, you get into like more complicated queries. So this distinct select is, it applies to all the columns, not just the one that precedes it. Like so distinct vend ID. Say if I had like prod name here, the distinct would be unique. You're selecting unique vendor IDs, product IDs, etc. So it applies to all the words that, all the columns that come after it. And so in this case, just select the distinct vendor IDs from the products. So notice how this has DLL01 a few times. Well, when you go to the datasheet view for this, it only has DLL1s because it only selects the unique. So that's how you use the distinct. So SQL, I guess the good thing about it is you just have like all of your queries like saved up, and you can reference them all. So I'm going to go up here and go to File. Oh, well, I updated my Access. So like I just want to, like, I clicked on my name up here and I clicked update, and then over here I went to File and I clicked Trust Enable Macros, because for the update function starting in like November or December 2019 they stopped working. So you need to update your Access in order to do the update function. It'll throw an error otherwise. So here's the top 5 select. So what this does is kind of useless. Select the top 5 of the product name. So whatever the top 5 is in these, it just selects them like in order. So yeah, it's pretty useless unless you're just trying to look at like the top 5. And then here's OrderBy. So OrderBy basically is like a sort on the data. So you select the product name from the table of products, and then you order by the product name. And what this does is it basically, so up here, if you go to design and you click run, that also will show you the datasheet view for this SQL statement. So whenever you write like an SQL statement, you go to create, query design, and then go over here to like orders, products, vendors. Here's like the design view. You go to SQL view, and it basically shows like what you selected from the tables. But I'm just going to, like, you just write your query here, and then you end it with a semicolon, and then you click run, and it'll show you the data that you just wrote in your query. So that's how you write like a basic query. And then you like right click it and you click save, and then it'll show up over here. But here is this one, and this basically just sorts it in ascending order alphabetically. And then here's order by columns 2 and 3. So this will order by the price, and then it'll order by the product name. So datasheet view. So notice how like the 349s, it goes from smallest number to largest number, and then it also sorts alphabetically the product name in association with the price. Like notice 8-inch teddy bear is lower than bird bean, just because the price is larger. So that's just like sorting. Here's like order by, and then descending order. Basically you have descending there. So this is basically just orders them backwards instead of forwards. Ascending order is the default. So here is a WireFilter. So basically you select the product name, product price from products, where product price equals 3.49. It's basically like writing under the criteria 3.49, but you run it, and then so it selects any of the products that have the product price 3.49. There are only 3 of them, so that's the where. Where is kind of like a filter. Here's a where with an and. So where the product price equals 3.49 and the product name doesn't equal business. So for any text characters, you just put a single quote there, and that's how you write the text characters. And let me go to the design view up here. So you write doesn't equal and then business over here. That's basically the design view for that. If you go to show table, and then you click products, and then you write these words here, it's the same as writing the SQL over there. So an and is these both need to be true. It needs to not equal business, and it needs to equal 3.49 in order for that to work. So notice how the product name doesn't have business in it, and they equal 3.49, so it shows it. So both of these conditions need to be true in order for the data to show. Whereas like for an or statement, if you do like an or statement, then one of them has to be true. Like it could either be 3.49 or it could not equal business. And then here are the and and the or. So you select the product name, product price from products, and then in parentheses you put a vend ID, where vend ID equals DL01 or the vend ID equals that. So it could either equal this or it could equal that, and then it will show. And then the product price has to be greater than 10. So this parentheses works how like it could be either of these conditions are true and it'll take it, and the product price has to be larger than 10. So the parentheses are kind of like you take that over the and. If you have the parentheses, it comes in order of operations. And then here's the in operator. Let me show what this is. looks like in design view. That's basically what that looks like in design view. If it's on like the same line, then it's an AND basically, and then it's an OR if it's on different lines. And then here is the in operator. So select the product name, the product price from products, where the vend ID is in this one or that one. It's basically in is basically an OR statement, and then order by product name. So in is another way of writing an OR statement. And then here is the design view of it. So it's basically like writing an OR except you write in, same thing. So it could either be DL01 or it could be BRS01. So here's that. So notice how these are those vend IDs. Alright. Here's the not. So select product names from products where not anything that isn't this it selects. So here's the design view, not equal to. So here's a wildcard. Wildcard's basically, it's like you use like a character and then for like words, and then it takes the place of actual letters. So you could search with less specific stuff, like say I wanted like fish, and then I put a star after it in the single quotes. So anything that has the word fish at the beginning, it will return that as long as the product name has fish. And it starts with the word fish and then anything that comes after it, however many characters. And here's the datasheet view. Notice how it returns just this record because that's the fish. And then here's like another one where you put where the product name is like, and then you put F star Y star. So this returns, as long as it starts with F and then ends with Y, then you return that. And then here's like a wildcard with the question marks. So you put like question mark, inch teddy bear, and then a star. I put a star at the end because Access it will add blank fields. Like it adds like blank characters at the end of certain fields sometimes. So if that happens, then you could just put a star at the end and then it'll still return it. So sometimes when you make access fields, it just has like blank spaces at the end. So if you like the question mark wildcard character is different from the star because the star could be however many characters and the question mark has to be exactly a random character for as many question marks as you write. So if I wrote just question mark inch teddy bear, it would just return the 8-inch teddy bear because that's the only one that has one question like one character and then space inch teddy bear. So that's the question mark. Here's the wildcard brackets. So here's select customer contact from customers where customer contact like JM. So you put this bracket and then you put that other bracket and then you put a star. So if the character starts with either a J or an M, then you return that. So it returns Jim Jones, John Smith, Michelle Green, and that's basically how that looks. And then here's wildcard characters brackets not. So where it's not, so you filter by where it's not like that. So over here, not like. Here's a concatenate function. So you select the vend name and then plus. Plus is how you write like concatenation. And so you put in parentheses and then like the whatever plus vend country plus And then here's an alias as expression1. So you select the vend name and then the vend country with like all these like parentheses and stuff, and then the name of the column is known as expression1 because this is like a calculated field from vendors, and then you order by vendors dot vend name, because you can't order by an alias. You order by the other thing. So here's basically what that returns, and then here's the column expression1. What it basically does is, so this is from the vendors table. Let me take a screenshot of vendors. So what this basically does is it takes the vendor's name and then plus the vendor's country. So Bear Emporium plus USA. And then here's what the data looks like. Bear Emporium plus USA. Bears R Us plus USA. So that's concatenate. You can just add the two columns together. And then here's concatenate, but with a trim function. So it clears like all the spaces, so it doesn't look crappy like this one. So in this one, you just RTRIM, which trims the right side of a string, and then LTRIM trims the left side of the string, and then trim trims both the right and the left side of the string. So it trims the right side of that from vendors, order by vendor name. And then here's like an alias to name select. So you do that, and then as vend title. So it's basically the same thing as the RTRIM one, except in this one we name it vend title. So that was just alias again, just to rename the calculated column. So here's a mathematical new calculated field. So in this one you go to, you select the, let me go to the order items, take a screenshot of this. So mathematical calculated field, you select the product ID, item price, and then quantity times the item price, and then as use an alias as expanded price, an alias. So from order items, and then where the order items equals 2008. So you only want these right here, and then you want like these columns, and then you basically create a new column over here called expanded price. That is the item price times the quantity, and you name it as expanded price. So here's what that looks like. Basically 5 times that equals that. So that's how you do calculated fields. You could also do like plus or minus, divided by, or minus. So that's a SQL mathematical field. So here's the now function. That basically just returns whatever time it is right now whenever you open it. So if you're working with data and you need to know what day it is, you could use the now function. Here's the uppercase function. So what this does is like vend name, ucase vend name, as vend name uppercase. So basically just makes everything uppercase. So you could work with the letters. I think L case is lowercase. Let me try that out. U case, L case. Yeah, so it makes everything lowercase. In case you need to work with the words and stuff. And then here's the len function. So the len function, the len of the vend name as vend name update, vend name length. So this just gives you however many characters there are in vend name. It happens to be just 50 for each of these, because each of these have blank spaces at the end of it, so just 50 each. But this one is actually 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually 9, but it's just 50 because it has blank spaces in the data. Here's the left function. So the left function, left of vend name, comma 1 as vend name. This basically just gives you the left, the first character of here. So it's kind of like Excel, the left function. Here's the date part. So what this does is, let me go to orders and take a screenshot. And scroll back to the date part. So for this one, what it does is it selects the order number from this table, and then where the date part, and you do the year, comma, and the order date. So you want all the years here where it's 2012, and you just want the order numbers for that. And you go over here to datasheet, and these are all the order numbers that have 2012 in the year. Here is the year function. Basically do the same thing, and then where year is order date 2012. Same thing. Here's the square root function, SQR, etc. Here's the abs function, absolute value. So if it's a negative, it just gives you a positive. Here's the average function. What it does is you do the average of the item price as the expanded price. And let me just scroll down on my notes. Yeah, this is basically just all the mathematical functions. Here's like a count function. So you count the item price as expanded price from order items. So let me go to order items. And so you count the item price, where the order items is this 3, 4, 5. So there are 5 2008 orders, and then this basically just turns 5 because you're counting however many have 2008 in the order number. So that's the count. Here's like a sum function. So you sum the item price. So this is a sum of all of these numbers here. 2745 is the sum of those numbers. Here's the count star. So what the count star does, select count star as num cost from customers. You go to the customers over here. So here are the customers. And what this SQL does is count star as number of customers from customers. So there are 5, so it counts however many columns there are, and it includes the nulls. So say if like one of these had like a null, there was like nothing there, it'd still count 5 because it includes everything. Here's the group by clause. So you select the vend ID. Let me go take a screenshot of products now. So this one, it selects the vend ID, and then it counts the number as the number of products. 1, 2, 3, 4, 5, 6, 7, 8, 9 from products, and then it groups by the vend ID. So here's like there are 4 of these, 3 of these, and then 2 of these. So here's what the group by does. It basically counts them for each of the things. So if you want to know however many there are for each of the things, you could use a group by clause. So you got there are 4 DL01s, and then here's SQL again. So it's basically you just count all of them based on the vend ID. And here's like a halving. So halving is basically the same as like a WireFilter, but you could only use halving on groups. You can't use where on groups, so use halving instead if you're working with a group. So let me go take a screenshot of orders. So you select the customer ID and then you count everything as orders from orders, and then you group by the customer ID. And then where they have more than 2 orders, and then here's the datasheet view. So 1001 is the only one. Here's one, here's another one. So it's the only one that has 2 orders. So here's how you could count the orders, and then only for whoever has 2. Here's a group by where and halving. So if you just wanted to select the vendor IDs and then all of them, count them from products where the product price is greater than or equal to 4, and then you group by only where they have more than 2 orders. So this is the products table. So let me just take a screenshot of this. So basically select the vend ID and then you count each of them. So see, there are 4 here, and then BRS and FNG. So it doesn't select these because these prices aren't greater than 4, and it'll count however many of these are greater than 4. So the product price has to be greater than or equal to 4, and then you group by the vending ID and you count them where they only have 2 counts. So if this only had 1 here, then it wouldn't include FNG. And also, if both of these numbers were just 1.49, then it wouldn't include FNG, because, yeah. And then here's OrderBy. It doesn't work with aliases. So here's like an OrderBy after. So it goes like select, from, where, group by, having, OrderBy. And also OrderBy doesn't work with aliases, as a side note. So that's basically that one. OrderBy, and then here's order items. Take a screenshot, show it next to the SQL thing. So what this one does is it does the order number, and then it counts all of them as items, a new column items, from order items, and you group by the order number. So group by is this, where they have count equal greater than 3. So 2005 doesn't have greater than 3, 2006 does, 2007 does, 2008 does, 2009 does. So here's the datasheet view, 2006, 7, 8, 9. So it doesn't include 2005 because there are only 2. Here's a subquery select. So this is, you could use 2 select queries in 1 query. So you select the customer ID. Let me go up to orders, take a screenshot. So basically, you select the customer ID, and then from orders, where the order number is in. So basically, it's either or. But in this in statement, it only has one thing. So select the order number from order items or product ID. So here's order items. Product ID is equal to argan01. So in this one, I guess I'll have to show the relationship between orders and order items. So order number is related over here, and then you're also, I guess, selecting the product ID in this case, which is in the order items table. So you want, in this select statement, you want the orders table, you want the order number, where it's argan01 in a completely different table. The subquery is pretty complicated. I mean, it's probably easier to just use join between the tables. Here's like an example of 3 select subqueries. So in this one, you select customer name, contact from customers, where the customer ID is in, and then you select the customer ID from orders, where the order number is in, and you select the order number from order items, where it's equal to that. So it's like 3 tables joined together by 3 selects. And then here's like a subquery count, the number of orders by customers by state. So in this one, you select, we got 2 tables. We got the orders table and we got the customers table. So in the orders table, you select these columns, and then you have a subquery select count from orders, and then where, use the where statement to join the orders table to the customers table. So let me go to relationships. So orders dot customers equals customers.id. So orders, here's customer ID, and then here's customers customer ID. So that's the linking key. Here's like, it's a primary key in customers table, and then it's a foreign key in the orders table. So there's only one particular customer, unique customer. They're all unique, and then they could do many orders, so they could appear many times in the orders table, but they could only appear once in the customers table, which is why you separate the 2 tables. So you join the 2 tables where they're equal as orders from customers, and then you order by customer name. So basically you're selecting the name, the state, and then the count of them from the orders, and then where they're equal. So fun for all is in both of the tables. So I guess you'd probably need to just have the tables to explain that. Well, here's like a join. So I go over like 3 different joins in this video. I'll go over inner join, left outer join, right outer join, and then union. So a join is basically you select the vendor name, the product price from the vendors, comma, products, because you're working with 2 tables here, and then use a where to join the tables. So where the vendor's ID, vendors.vendID equals products.vendID. So we're working with the products and the vendors table. So here's the vendors, here's the products, and then the vendID is the linking thing between them. So in this one, we just want to return these 3 columns from these 2 tables, and you only want to join them where the vendor ID is in both of them. So here's what that returns. And here's like the vendors, and here is the products. So here are the vendor IDs. DLL01, BRS01, and FNG01. So here's DLL01. So it's basically these 3 columns right here. So what we return in this is the vendor name, product name, and product price. So we return this vendor name, Bears R Us, product name, which is over here, and then product price, which is over here. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 records are actually underneath when you expand, like the BRS01, the DLL01, and the FNG01. Because here's like the product names here, etc. So that's like an inner join. Here's how you can like join multiple tables. So you select these columns, and then from order items, products, and vendors, and then you join on where products.vend ID. Since these are the same columns in each of these 2 tables, you have to write the table name before it with a period. So table dot this column ID. So we're working with what? Products, vendors, order items. So we're working with these 2, and then this one over here. So basically you select the product name, the vendor name, the product price, and the quantity. All this data is in different tables, and you could link them because the tables are linked by the keys. So, and then you select from table, comma table, comma table, and then where products table dot vend ID. Let me use a highlight for this part. So where this vend ID equals the vendor's vend ID. So each of the vend IDs in this table are unique. That's the primary key. And then here's the vend ID over here. There could be multiple vendors. Like the vendors could each have multiple products that they deliver, but each of the vendors are unique. And then each of the products are unique, but for each of the orders, each of the order items can have multiple products, but each of the products themselves are unique. So basically where the products.vend ID equals the vendor's vend ID, and then the order items prod ID equals the prod ID up here, and then the order number equals 2007. So that's how you can join multiple tables, and that's the information you get. So here's multiple joins with table aliases to short the table names. So we work at customers, orders, and order items. So in this one, let me delete all this junk. Alright, so in this one we work with customers, orders, and order items. And then when you're working with it, you use an alias. So you use customers as C, orders as O, and then order items as OI. So it just basically renames the tables into a shorter letter or whatever. So we're c.custid. It's basically customers.custid, except it's shorter. So here's customers custid, and orders.custid, and then all that other stuff. Basically the same as the last example, except in this one we shorten the table names with an alias. Here's the left outer join. So this includes customers and orders. And the left join, when you write left join, it basically includes all of the customers who also don't even have an order. So even if the customer doesn't have an order, it'll include it, because the left join, it applies to whatever's to the left of it in the from. And then the right join, it includes, like if I did right join here, then it would include all the orders, even if a customer didn't order it. So over here, you got this customer, he didn't have an order, so you include that. And then, let's see, right join. Got all the orders actually ends up having customers. So there isn't an order that doesn't have a customer, but if there was an order that didn't have a customer, then it would include it here. Here's an inner join. It's the same as like the where statement, where you use like it's the same as this from the two tables, where equals that, but you could use just inner join on. So it's basically the same thing, it's just different syntax. And then here's an example of right join. I already did that. Here's a full outer join, or a union. So in this union, you basically select all the columns from vendors. Let me scroll through my notes real quick. So basically it combines like all the records in each of the tables, and they have to have the same columns, and expressions or aggregate functions, and all the column data types must be compatible. The union automatically removes any duplicate rows from the query. If you use a union all, it includes the duplicates. So in this one, you select star from vendors as V, and then you left join products as P, and then basically do a left join, and then you do a right join, and you put a union in between them, and then here's the union icon. So basically it takes all the columns from these two tables and it puts them together, and it removes any duplicates. So let me go to my notes over here. So this union over here, it has all these, and then union all, it includes the Fun for All Jim Jones duplicate record. If you use union all, then it includes the duplicates, because this is in both of the tables, and then the union, it just eliminates the duplicates if the same record is in both of the tables. So that's the union. And then here's an aggregate count on an inner join. So it basically counts the number of orders by each of the customers. So select customers, customer ID, and then you count the orders from customers, and you do a join on the orders, on the customers, and you group by the customer ID. That sounds impossible. So here is a left join count. So it counts the number of orders by the customers, and it also includes, since it's left join, it includes the customers who don't have orders, and it puts a 0 next to it. So here's how you do that. and then here's a union where it's the same table. So union, you select the same columns in each of the tables from customers, and then where the customer states in here, and then union select this from customers where the customer name is fun for all. So it's basically a union of the same table. It sounds kind of stupid. Here's 3 rows of the first select union. I'm just gonna skip this. Here's a union all. It includes the duplicates. So you basically write union all. So notice how fun for all is in both the tables. That's why it includes both of them. So here's a union, and then with an OrderBy, if you ever need to sort them, you just use OrderBy once at the end, and it applies to the entire thing. And then you just write whatever columns you want. So it's basically that. You could sort with a union. So you go to, if you want customers for orders, for all orders that aren't orders, you do where o.order is null. That'll give you something. So here's a select into. So what this does is it selects the star so it selects all the columns from customers, and it puts it into a new table called customer copy. So right now I don't have a table called customer copy, but I'm going to click run on this, and you're about to paste 5 rows. Yes. So here's customer copy. So you just made a table called customer copy with this SQL up here. So I'm just going to close this, and over here is insert into customers table. Let me click no and go to design view. So insert into customers. So the customers table has 9 columns. I'm going to insert a new record that has 9 columns into here right now. So I'm just going to press go to design, click run. You're about to append 1 row. Yes. So now the customers table has a new row called 11111. Close that. Let's go to insert into customers table, new customers table. So go to design view. So I want to insert into customers, and then you select the star from customer new. So here's a customer new table. This also has 9 columns. So I'm going to select all the columns here, and I'm going to insert them into the customers table with this. So here's customers initially. Let me close that and click run. Yes. So now here is the customers table now. So here is a new. So it just added that column there with the rows. Here is an update query. So an update query, whenever you click it actually runs the macro, but let me just go to design view and I'll click run. So you could actually run queries from Excel too. So go to update customers, set customer email. So in the customers table, I want to set the customer email equal to new email at email.com. Here's the email column where the customer ID is 1005. So it's just going to update the table with this information for this customer. Click run. Yes. So now when you go to the customers tab over here, here's the new email over here. It was initially nothing, and now it is new email. Here's an update for multiple columns. Go to design view. Let me close this and close this. So update customers, and when the customer contact is Sam Roberts and the customer email is that. Oh, yeah, where the customer ID is 1006. Let me just put 1005. Click run. Design, run. Yep. Go to customers. And here it updated this dude. So that's how you could update multiple columns. Here's update, use null to save values. So here's design view. So I'm going to set the email equal to blank, where the customer ID is 1005. Let me just close out of this one and this one and click run here. So here is the customer, and now he no longer has an email because this equals null. Just remove that. So here is the delete query. Go to delete everything from this table customers where the customer ID is 1005. Here's a delete query. The reason that, so Microsoft, it can't delete one record. The reason why I can't delete a record is in the relationships tab. So if you go to customers over here and you go to edit relationships and then select like customers and customer ID. So over here I did enforce referential integrity. So when I and I don't have cascade delete related rows, records, and cascade update related fields. So whenever you update a primary key related item, it'll flow through to the other tables if you set up the relationships that way. So let me do that and press OK. And then go over here to save and close. So I'm going to delete everything from customers where the customer ID is 1005 now. Yes. I guess enforce referential integrity. Oh wait, let me close out the table and then go to edit relationships and that, press that, save and close. So let me delete this customer right there. So now the customers 1005 is not there anymore because I deleted it. And the reason I was able to do that is because I turned off referential integrity from the relationships. So now let me go back to edit relationships and customers, orders, and enforce referential integrity. So you can't change it if the table's open, but over here, press OK. So here is a create table query. So in addition to updating, inserting tables together, and deleting tables or deleting information in tables, you can also create tables. So go to design view. So it's going to create a table called products 3, and then basically you just provide like the column name and then what type of table it is, and then you write like not null. The default is null, which allows for blank values. Not null, if you're making like a primary key, then you use not null, because primary key has to exist. But if you just write nothing here and just put like a comma, then it just defaults to null. So I'm just going to click run. So what this did is it created a products 3, and then here are the different columns in there, which I specified. It's kind of like going up here and going into create table, and then just writing the column names here. Here is alter table. So what this does is it alters the vendors, and it adds a new column with 20 characters. So here's how you could add a column to the vendors table. So here's the vendors table first, beforehand. And then this adds a column there. So here's it before, and here's it after. Now it has a new column called vendphone. Let me close all these out. And then here is a drop column. So drop column, it alters the table of vendors, and it drops the column we just made, vendphone. So I'm going to click run. So now vendphone is no longer there. Here is drop table. This deletes the table. So drop table products 3. Click run. So products 3 is gone. And create table with the references foreign key. So this is how you create a table called orders2, and then integer not null primary key. Here's how you designate the primary key, and then here's how you reference the customers table customer ID. So here's how you could create a table called orders2 that has this as the unique primary key, and then this as how it relates to the customers tab. So click run, and that creates the orders2 tab table. And then here's a create table unique. So you go to design view, and not null unique is how you do, like, it has to be a unique kind of thing. And like foreign keys, they enforce referential integrity when you do that. So when you update the tables, they'll flow. And that's basically this video. I learned that from reading this book on Amazon.